Hey, in this video, I wanted to go through how we would solve the different type of square root problems. So I have a couple of here. You are going to notice that on any practice and on your test, you're going to have a chart that has the numbers 1 through 30. I'll talk about where to find stuff on that chart, but I'm not going to take the time to upload that image because I have most of them memorized. All right, as we're starting to solve these problems, the first step is going to be to get x squared by itself. And I'm going to write these steps off to the side. As you're doing this, what you need to make sure that you do is you're writing out all the steps. So both I as the grader and you as the person trying to do this see what's going on. Too often I have students being lazy and not writing out the steps, and not only are you making mistakes, I can't use your work to give you any sort of points. So we'd start and we would get x squared by itself. The same rules for solving a basic equation apply here. I see multiplication, I divide. And this is going to give me x squared is equal to 144. Now, my next step, I'm going to try square rooting both sides of this equation. If it works, cool, I can be lazy and I'm done. If not, and I get a decimal, that's going to tell me I'm going to have to do something else. For all of these problems with the square root method, we will never have decimals. So then I am going to square root both sides of this equation. And the square root of 144, and how I would do that is I press the second button on my calculator and then the x squared button. The square root of 144 is 12. Now for all of these problems, I am then going to put a plus or minus, and whatever my variable is drops down. One of the biggest mistakes that I see is that we forget that plus minus. You need to show that. Now, as I'm doing this, I also want to point out at every single step, both you and I can see what's going on. The second I don't do that, the second you don't do that, it becomes much harder because you suddenly go, wait, what am I supposed to do? Why am I doing this? And you have those questions because you don't see what's going on. All right, let's talk about a different problem. Again, what I'm going to do is I'm going to get x squared by itself. So I'm going to add 3 to both sides. I would divide both sides by 4. I'm going to go back and change this problem because otherwise we're going to have a problem exactly like the last one. So I'm going to change that 4x squared to a 2x squared so that I actually have something to show you. All right. So there I've gone and I've gotten x squared by itself. Again, I'm changing the problem because I'm lazy. I actually want to do something different. Then I'm going to try square rooting both sides. So on my calculator, I would type the square root of 200. That is going to give me 14 and then some decimal. Okay, this tells me at this point that I need to reduce my radical. When I reduce my radical, I am trying to find what perfect squares are hidden in this problem. So on your chart, one side is going to say, hey, here's 1, 2, 3, 4, and so on to the second power. We don't care about those numbers. What we care about are the numbers to the right. Okay, so here's the first 12 numbers to the second power. And then what I am going to do is I am going to take each of these numbers and I am going to try 200 divided by them. So I'm going to try 200 divided by 121, divided by 100, divided by 81, and all the way down. Now, as I'm doing this, how I knew to start here was because I took 200 and I divided it by 2, and that's roughly 121. And as I'm doing this, what I want to do is, as I'm guessing and checking and dividing these numbers, I want to see if it gives me a decimal or not. So when I take 200 divided by 121, I get 1.65. I don't want to use this. We don't like decimals. Next, I would take 200 divided by 100. That gives me 2. Okay, so another way to say this is that 100 times 2 gives me 200. I want the perfect square and I want the number that goes with it. What my work looks like. And here what I'm going to say is we're into the next step of guess and check division. So I know 200 is the square root of 100 times the square root of 2. The next thing I would do is I'm going to square root those two numbers. I'm square rooting both of these numbers to make sure that if I wrote my two things in a different way, I still get the right answer. I do not want you to fall into the trap of, let's say you go, oh, hey, this is 2 times 100. And you just assume that this is going to reduce into 2 square roots of 100. The order in which we write these does not matter. So to make this work, we're going to square root both numbers. The square root of 100 is 10. The square root of 2 is some awful decimal. So I'm going to write this as the square root of 2. This is my reduced radical. It is not my answer yet. To make it my answer, I'm going to put the plus minus sign there and slap an x equals onto it. So what you've seen us do is we tried square rooting things up here, got a decimal, and knew to check the chart. Then when we were checking the chart, we were dividing until we stopped getting a decimal. Those two whole numbers are what 200 break down into. And I square rooted both of those numbers. The thing that wasn't a decimal, I write down. Decimal doesn't get written down. There is one more type of problem that I want you to be able to do. Once again, our first step is to get x squared by itself. So I would do my inverse operation of adding 121 to both sides. I would go and divide both sides by 400, and 121 divided by 400 gives me 0.3. Now, I've spent a lot of time saying, hey, we don't like decimals. When I get this, what I'm going to do is I'm just going to erase my decimal, I'm going to write what I have. Right now, I have x squared is equal to 121 divided by 400. I am not going to divide those numbers. Instead, what I am going to do is I am going to square root both sides. And what this is going to look like is I'm going to take the square root of 121. I'm going to leave that over. Now we're treating this as a fraction over the square root of 400. And we're going to see what happens. So the square root of 121 is 11. The square root of 400 is 20. And once again, I'm going to slap plus minus on this, and I'm going to write x equals here. Again, how did I know to do this? Because I was getting a decimal here and not me trying to square root a number that already was divided. Now, as you're looking at my work, the single most thing that you can really copy and do is make sure that your work looks like mine. Again, at every single step, I can look at this problem and say, hey, this is what I have. And based on what I have, this is what I'm going to do. Here we see, oh yeah, he was dividing. And when I went and I was changing it up and I was going to shift gears, you see me keep the same work. And then even in here, I am writing what I am doing. The less work you show, the harder it is for you to see what's going on, the more chances you have to make a mistake. So as you're doing practice, make sure your work looks good. It's organized. It's neat. You can look back and go, yeah, I see what I'm doing. Because if you don't, it makes this problem so much harder. Otherwise, here's 3 quick examples about how to solve using the square root method. As you have questions, please be sure to email me. And oh yeah, have good work.